All right, everyone. So in this lesson, we're going to be learning about limiting and excess reactants. And we want to go ahead and get some definitions down. So before we do that, though, remember reactants are on the left side and products are on the right. So when you have a chemical equation, you have reactants, and then you have your arrow showing that what's on the right side is being produced. So when we're talking about limiting and excess reactants, we're talking about your ingredients, the things that you start with in a chemical equation or that you start with in a lab. So a limiting reactant limits the amount of product made. And the reason why it limits the amount of products is because it runs out. Okay, so because it runs out. So we know that if you have a balanced chemical equation with our mole ratio, it requires a certain amount of each ingredient to create our products. So if you run out of one of them, you can't make any more product. An excess reactant does not limit the amount of products. There is more than enough. So more than enough, and typically there is some left over, okay? And so we're gonna just see the different ways that you could be asked about these concepts through several different types of examples. So in this first example, we've got a particle diagram. We see that we have hydrogen reacting with oxygen, and at the end, we have hydrogen and oxygen both present. So imagine that you have beaker A and beaker B, and then you combine them together, and this is what you get. And so we notice that these two compounds are reactants, okay? They're present at the beginning. And at the end, you have water, which must be a product because it was not there at the beginning. And you have oxygen, which is a reactant, okay? And so the oxygen is this one right here. So when we're trying to identify which one is the limiting reactant and which one is the excess reactant, we see that O2 is the excess reactant because it's present at the end. So it's there at the end. Whereas, and that makes H2 the limiting reactant because it runs out. Okay, there is none left over at the end. So you have the beginning and you have the end. And there's no hydrogen at the end, so it must be the one that ran out. Okay, so what about this? What if you're given it data, okay? So here we see that they're doing trial 1, trial 2, trial 3. So they're doing the same experiment 3 times. We see that at the beginning, when they start off with the same amount of each, so they have the same amount of both reactants, they produce 20 grams, okay? And when in trial 2, the amount of reactant 1 doesn't change, but the amount of reactant 2 increases. But when we increase reactant 2, there is no change in the amount of product. So that tells us that reactant 2 must have already had more than enough to begin with. So this one must be in excess because when I add more, there's no change in the amount of product. Whereas when we do increase the amount of reactant number 1, and this one stays the same compared to trial 2, we see that there is an increase in the amount of product. So this must be the limiting reactant because it is the reactant that's determining how much product you can make based on its amount. So we can see that reactant number 1 is limiting and reactant number 2 is our excess reactant. There's a third example here. So it says the data table to the right, or in this case actually below it, shows the information collected during an experiment based on the following reaction. So we have 2 moles of aluminum plus 3 moles of copper sulfate producing 1 mole of aluminum sulfate and 3 moles of copper. And it says label which chemical is the limiting reactant and which one is the excess. So remember, if we have reactants on the left and products, I don't know why I started off that word with an S, but we have products on the right, okay, then we only have 2 options. These are the only possible answers. These chemicals cannot be a correct answer because they are products. To be a limiting reactant or an excess reactant, you first have to be a reactant. So they tell us some observations. They say the aluminum is a shiny silver solid and the copper sulfate is a blue liquid. Cool. And then in our final observations, it says when mixing them, there appears to be a red solid forming. So that must be a product because it's new, it's being created. The liquid turns completely clear. Okay, so that means there's no blue liquid anymore. Okay, because it's all clear and there's still some silver solid underneath. Okay, so the silver solid was the aluminum. Okay, so if there's no blue liquid and there is some silver solid or our aluminum, that tells us that the copper sulfate, which was the blue liquid, ran out, and that makes it the limiting reactant. Okay, whereas the aluminum was still there, so it must be the excess reactant. So what that means, if I were to add a little bit more copper sulfate to the beaker that this reaction is happening in, it would continue to react because we would have added more of our limiting reactant. So you've got some practice problems here for you to help with your studies. So hopefully you understand the idea of limiting and excess reactants because we're also going to talk about them with s'mores.